Okay, the next concept is basically series. Coming to what a series is, as I said earlier, a series is nothing but the sum of a set number of terms in a sequence. It could either be a set number or an infinite sum also. Infinite sum means, say we take this sequence 1, 3, 5, 7, 9, 11 and so on. And if we say that the terms never end, so we go on and on all the way to infinity, that is an infinite series. So it never ends. Also, I can decide when the series ends. I have the freedom to choose when the series ends. If I say that it ends at 10 terms and I want to find the series, that is basically the sum of first 10 terms of this series. Okay, so this is basically what a series is. Nothing but the connection of different terms by a plus sign or a minus sign between everything. Now, if I have to generalize this, also over here we're looking at sum of an arithmetic series. The example that I'm giving you, 1, 3, 5, 7, this is an arithmetic series. So if I generalize this, it comes out to be a first term plus a plus d second term plus a plus 2d, a plus 3d and so on. And if I say that it stops at the nth term, if the series stops at the nth term, that is basically a plus n minus 1d. So this is the last term. This is the generalized sum of a progression of n terms. Okay, that is what I have written out over here. I'll just give some interesting facts about an infinite arithmetic series. So infinite meaning that the number of terms never ends. So it just keeps going on and on and on. Whatever I take the series as a plus d, a plus 2d, dot dot dot, all the way till a plus n minus 1d, its sum is always infinite. Sum is always infinite. This is for infinite AP. Alright, only in one case where both A and D are 0. So if both A and D are 0, we just have 0 plus 0 plus 0, that is 0. But in any other case, if I take, the sum is going to be infinite. Of course, if I take the common difference as negative, so let's say I take the series as 1, minus 3, minus 7, minus 5, so on. If I take this, I will get a sum of minus infinity. Clearly, as you can see, term by term, we're getting larger and larger negative numbers. It will be minus 7, minus 9, somewhere down the line, then minus, say, 1, 0, 1, and so on. Alright, so this is basically what a series is. Now there are some interesting kind of series. I'll give you some examples. Like say 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. This is basically the reciprocal of natural numbers. It does not end over here. It goes on till infinity. Now let's say a term, thousandth term, 1 by 1000. We know that this is very small number. It is 0.001. If I go to even a father term or a larger denominator, let's say I have 1 by 10 power 10. This gives me 10 power minus 10. It is a very small number. Okay, so as I keep going towards infinity, I basically reach a point where I have a number so small I can say that it is pretty much 0. So you see, I'm starting with 1, going to half, 1/3, 1/4, so on, and eventually I'm coming to such a small number. Just interesting series I'm pointing out. The sum of this infinite series comes to infinity, plus infinity, even though the terms which are very far away are so small that they're approximately 0. Alright. Also, the general term of this series, let's say the nth term, you can see it's 1 by, as the terms are going 1 by 1, 1 by 2, 1 by 3, 1 by 4. So the nth term is nothing but 1 by n. This is the nth term. Of course, the details of this are not important for this lesson or your examination at the moment, but the more knowledge we have, the better idea we have of mathematics. Okay, so let us try to get a standard formula for the sum of the first n terms of an arithmetic progression. So this is the first term, second term, third term, so on, and this is the nth term. Alright, so I'm going to try to get a standard formula for the sum of first n terms of an arithmetic series. So the steps to do this are, first I've laid down S I'm writing as the sum that I'm looking for. Next step, I've laid down S in reverse. Okay, what do I mean by S in reverse? So I started with the last term over here. This is the nth term. So a plus n minus 1d, this is the last term. What is the second last term now? Second last term is the n minus 1th term. N minus 1th term. So this is a plus n minus 1 minus 1 times d. So a plus n minus 2d. Then I have the third last term, that is the n minus 2th term, a plus n minus 3d, and so on all the way till the first term. I'll explain why I've done this. So if I take a sum of two equations, equation number 1 plus equation number 2, if I take a sum of these two, so let's say adding the first term and the nth term, adding the first and the nth term, I get 2a plus n minus 1 times d. So also if I add the left hand side over here, s plus s, that is 2s. So I have 2s and the first term is 2a plus n minus 1d. Let's see what happens if I add the two next terms of both the first series and the second series. So I have a plus d plus a plus n minus 2d. This becomes, so if I open this up, I'll get 2a plus b plus nd minus 2d. That becomes 2a plus n minus 1d, which is the same as this. So these two terms are equal, and the same we're going to get for all the terms. Let's just do it for the last term and check once. Now the last set of terms, which is these two, gives me a plus n minus 1d plus a, which is nothing but 2a plus n minus 1d, which is the same as what I got for the previous two. So you can see that there's a clear pattern, in fact not even a pattern, a fixed value we are getting for adding the terms equidistant from the ends. What do I mean by equidistant from the ends? So first plus last is equal to second term plus second last term is equal to third term plus third last term, and so on, which is equal to 2a plus n minus 1d. So 2s, which is the left hand side over here, 2s is equal to all these sums. It is first plus last plus second plus third last, fourth plus fourth last, and so on. So you can see I have this expression: first one time, second time, third time, and clearly there are n terms in the series. If there are n terms in the series, I basically have n times 2a plus n minus 1d. This is what is equal to 2s. If 2s is given as 2a plus n minus 1 times d, whole thing times n, what is s going to be? I just have to take this coefficient 2 to the other side. I get n by 2 times 2a plus n minus 1d. Now this derivation is not required for school, but you need to understand how exactly we're getting this number. Alright, so this is the sum of n terms of an AP. Let's try to determine a very interesting result from this. That result is basically the sum of first n natural numbers starting from 1, 2, 3 all the way up to n. We can see that the natural numbers are actually an AP. This forms an AP with common difference 1 and first term 1. Okay, so by the formula that we just learned, S is basically n by 2. The first term, so or rather 2a, so that is 2 plus n minus 1 times d, which is 1. So you have n by 2 times 2 plus n minus 1, that is n by 2 times n plus 1. So two things from this. First, we got the formula for sum of first n natural numbers, and the second thing is inside this bracket we basically have two factors. First of all, this is the first factor n, and this is the second factor n plus 1. Now inside the second factor n plus 1, you have the first term plus the last term. So 1 plus n, that is first term plus last term. So the formula for sum of AP can be simplified to number of terms by 2 into first term plus last term. So this is the same thing as number of terms is n by 2, first term is a, and last term is the nth term, that is a plus n minus 1 times d. So this is how I get n by 2 times 2a plus n minus 1 d. Okay, so we'll just look at a few more problems. Okay, another problem. This one is fairly simple. So let's just read the question once. It says find the 60th term of the AP 8, 10, 12, so on, if it has a total of 60 terms, and hence find the sum of its last 10 terms. So we're not asked to find the sum from the first term to the 60th term, but instead the last 10 terms. Okay, so let me just find this, write down this AP and write down what its common difference and first term are. Okay, so first term is clearly A. Start with 8, 10, 12. Next term is going to be 14 and so on. So A is equal to 8. Common difference is 10 minus 8, which is 2. So the nth term or the general term is going to be A plus n minus 1 times d, that is 8 plus n minus 1 times 2, which is, this is nothing but nth term. Okay, so I've determined its nth term. The series has a total of 60 terms. Okay, and I need to find out the sum of the last 10 terms. Let's start now. So the last 10 terms will be starting from the 51st term, then 52nd, and so on till the 60th. So first of all, there are multiple ways of doing this problem. One of the method, I'll write down over here, method 1 is to find out sum of first 60 terms, sum of 60 terms minus sum of 50 terms. This is basically equal to sum of last 10, sum of last 10. Method 2, now there is the second method of solving is I can directly find sum of the series which starts with the 51st and goes all the way till the 60th term. Now one interesting thing to note about AP is if from the middle of an AP, let's say I have this AP 8, 10, 12, if from the middle I take out any number of consecutive terms, let's say I have the AP, the simplest AP 1, 3, 5, 7, 9. If I take out 3 consecutive terms from this AP, 3, 5, 7, it is always going to remain an AP. So if I take out any number of consecutive terms from an AP, the result is also an AP. So over here in method 2, I can basically construct an AP with the new first term as the 51st old term. Okay, 51st old term, and go with the same common difference all the way up till the 60th term. So I'll leave method 1 to you. I'll solve the problem using method 2. So writing down the AP again, 8, 10, 12. A is 8, CD is 2. 51st term. Let's get the 51st term. That is basically 8 plus 51 minus 1 times 2. I'll write the formula over here. This is A plus n minus 1d. Okay, so I have 8 plus 50 into 2, that is 108. So 51st term is 108, and 60th term will be, yeah, 8 plus 60 minus 1 times common difference 2, that is equal to 8 plus 59 into 2. 59 into 2 is 118, so that is 8 plus 118. This gives you 126. Okay, so I've reconstructed an AP where this is now the new first term. Okay, now let's use the formula for sum of AP. So sum is basically number of terms. So number of terms over here is 51st term to 60th term, that is 10. 10 by 2 into first term, which is 108, plus last term 126, and this is directly the answer. So this, once I solve this, this gives me the answer. This is 5 into 108 plus 126, which is 234 into 5. Correct? Yeah, 234 into 5. The answer is 1170. So this is the sum of the last 10 terms. Okay, if you had trouble following, you can just either slow down the video or go through this question again.